Dear student, welcome to the online learning. Today we will learn about chapter number 2, that is whole numbers. Today's topic will be properties of whole numbers. So let's begin with our today's learning. So here comes our first property, that is closure property of addition. So children, you can see here that we have taken the two whole numbers and that we have added, and while adding them we have obtained its sum, that is equals to 12. So you can see this sum is a whole number. In the same way, if I talk about the another example, there also we have obtained the sum is equals to 10, which is a whole number. So this closure property of addition states that on adding any two whole numbers, the sum is still a whole number. And the same way, let us discuss regarding the closure property of multiplication. So children, let's take example here. So as such, you can see we have taken two whole numbers, that are 5 and 7, and on multiplying them we have obtained the product is equals to 35, and this product is a whole number. In the same way, you can just observe the second example present on the screen, and with this, you can say that the closure property of multiplication states that on multiplying any two whole numbers, the product is still a whole number. Now, let us move to the next property of whole number. So, that is associative property of addition. So, children, here you can see that we have taken this time three whole numbers present on the screen, and you can see the two whole numbers that are present inside the bracket. So, that we are going to solve first. Okay, so by adding them first, you can get their sum is equals to 5, and then later on this sum we can add with the third whole number, that is with 4. So by doing so, we have obtained the answer is equals to 9, or else these three whole numbers, they can be added in such a way that by adding these two whole numbers, that was the next two whole number, first we will add. Okay, and then later on, after obtaining the sum for this next two whole number, we have obtained the sum is equals to 7, and this sum later on we can add with the first whole number, that is 2. So by doing so, you can see the sum we have obtained is equals to 9. Means in both the way we can perform the addition. Okay, so while doing so, you can see that we have obtained the same answer. So children, this associative property of addition states that on changing the grouping of three or more addends does not change the sum. Now here comes another property, that is associative property of multiplication. So here also you can see that we have three whole numbers, and here you can see the first two whole numbers are kept inside the bracket, that we are going to take it first, and that product you will find first. So by doing so, you have obtained the product is equals to 6, and then later on that product we are going to multiply with the third whole number, that was 4. So by performing this all step, you have obtained the answer is equals to 24. Now let's take again the same three whole numbers, and you can perform the multiplication for this three whole numbers in such a way that by taking the next two whole numbers first and by getting their product first. Okay, so let's see what we can get by doing so. So when we have taken the next two whole number first, and when we have obtained the product for them, we have obtained it is equals to 12, and then later on when we have multiplied the product of this next two number with the first whole number 2, then the final answer we got, that is equals to 24. So children, we can say that this associative property of multiplication states that on changing the grouping of three or more factors does not change the product. So here comes another property, that is commutative property of addition. So let us understand here what does this property says. So you can see that here we have taken whole number like 3 and 4. Okay, and you can see we have taken the same whole number, both the side of this equals 2. Okay, so when I talk regarding this left hand side, you can see the first whole number I have taken as 3 and the next whole number I have taken it as 4, and when I obtain its sum I will get it 7. Now if I talk about the right hand side, you can see the first number that was the second number when I have done the sum left hand side. Okay, and this next number in my right hand side was the first number in my left hand side. Okay children, so by performing the addition on both the side, by changing the order of the number, we have obtained the same sum, that is equals to 7. So we can say that by changing the order of the addends does not change the sum. Why so? Because you can understand this thing by taking help of this more example that are present on the screen. As such, when we add the first number with the second whole number and without changing the number, when we change the order of the same number, that the number which we have taken first, if we take it as next number, and the number which was taken as the second number, if we take it in the first order, and while taking their sum, we'll get the same sum on both the side. Now let us understand about the commutative property of multiplication. So children, here also you can see that on both the hand side we have taken the same two whole numbers, that are 7 and 2. Okay, and here also you can see my first number on the left hand side was 7 and the second number was 2. Okay, and when I talk about the product obtained in left hand side, that will be equals to 14, whereas if I talk about the two whole numbers that I have taken it in the right hand side, that was 2 and 7. So when you will observe, you can understand this thing, that this number 2 in my left hand side was the second number and the 7 was first number, whereas when I have taken this same number in my right hand side, I have taken the second number of the left hand side as the first number in right hand side, whereas the first number of left hand side I have taken as second number in my right hand side, and while doing so the product I have obtained, that is 14, means in both the side we have obtained the same product. So children, we can say that this commutative property of multiplication states that on changing the order of the factors does not change the product. Okay, you can understand this thing with the example present on the screen, that if we want to obtain 54, okay, so the factor for this 54 are 6 and 9. Okay, so if we multiply 6 with 9 or either we multiply 9 with 6, we are going to get the same number, okay, as a multiple of it. Now here comes distributive property of multiplication over addition. So children, you can see that we have multiplied 2 with 7 and we obtain the product is equals to 14. Now let us understand this thing. As such, you can see now next time we have taken 2 outside and that we need to multiply with the 2 addends present inside the bracket. Okay, so if we take this first number, that was 2, and if we multiply this 2 with the first addend, that is 3, so what we'll obtain? We'll obtain it is equals to 6. Okay, now in the same way, if I take the first number 2 and if I multiply it with the second addend, that was 4, so you will see that the product we have obtained, it is equals to 8, and later on when we take the sum of these two numbers that we have obtained after multiplying, that was 6 and 8, so the sum we have obtained is equals to 14. So children, you can see in both the case we have obtained the same answer. Either we solve the numbers which are present inside the bracket and then we multiply with the number which was present outside of the bracket, has given us the same answer that we have obtained when we have multiplied the first number with the first addend, then again the first number when we have multiplied with the second addend. Okay, So we can say that this distributive property of multiplication over addition states that when multiplying a sum by a number gives the same result as when they are multiplied by each addend by the number and then when that are added. Okay, and always remember that this above property, whatever we learned, they do not hold for subtraction and division. Now here comes identities. So children, first of all we'll learn about additive identity. So as such we know, when we take any number, counting number, and when we add 0 with it, okay, so we get the counting number only. As such, let us take another example also. When I take 5 and when I have added with 0, I have obtained 5 only. In the same manner, if I take next number, that was 7, and when I added with 0, I have obtained 7. So you can see that a whole number 0 is called the additive identity, since when it is added to any whole number, the sum is identical to that whole number. Now here comes next identity, that is multiplicative identity. So children, you can see I have taken here 6, and when I have multiplied this 6 with 1, I got 6. As such, when I have taken next example, that is 5 multiplied with 1, I have got the multiplication for this two number, it is equals to 5 only. In the same manner, you can just see here, when I have multiplied 7 with 1, I obtain 7. Or you can see this next example also. So what does this multiplicative identity says? That the whole number 1 is called as multiplicative identity, since when it is multiplied to a whole number, the product is identical to that whole number. Means you can understand that a number remains the same when we multiply it by 1. As such, you can see from this examples present on the screen. Now here comes your home assignment, that you have to solve question number 1, and in this question number 1 you need to find the product for this 3 whole number using associative property, and second question is that you need to use distributive property to solve this. Okay, so children, I hope whatever we learned today you have understood properly. Complete your notebook. Thank you.